We're going to take a look at another tool here, and this isn't necessarily useful for port scans in a traditional sense. What it is good for, though, is creating packets on the command line and sending those repeatedly so that you can get responses back. And that may not make a lot of sense, so let me actually just show you, and then we can talk about it as I'm going. I'm going to get some verbose output. I'm going to set my SYN flag, and then I'm just going to say my port is going to be 80, and then I'm going to say my target is 192.168.86.1. So you can see what's happening here is it's sending out a message with the SYN flag set and then paying attention to the responses back. So here, and let me just kill this, the length is 46, the IP, we've got the time to live, the don't fragment bit is set, ID is 0, type of service is 0, IP length is 44. We've got the source port, and then we've got the flags, and this is on the response back. So remember, when we send a SYN, we expect a SYNAC back, and that's exactly what we got. We got a SYNAC back, and the sequence number keeps incrementing. The window size remains the same. We've got a round trip time as well, the sequence number, the acknowledgement number, and none of these should have anything to do with one another. They should all be random because really it's going to look like a number of different initiations of connections that are happening. So every time we send a SYN, it's a new connection that's happening. The other thing that I can do here is rather than the SYN, let's send the FIN flag. In this case, I've got the F set, and we're not actually getting a response with just the fin flag set. We've got nothing there. What I can do also is I could say minus S, minus A. So this is the SYN flag, the ACK flag, and the fin flag. And then we're going to, again, just send it off to port 80. And in this case, we are getting a response back. So what we get back here is we get a reset message for every message that we send. And again, we get the same detail that we got initially. We get some good detail that way. Now, I can also do just a regular ICMP. So I could say ICMP, for example. And in this case, we're just sending out an ICMP message just as you would with a regular ping. And so that's an echo request. And it looks fairly traditional, just as you might expect a regular ping to look. So I could also do UDP, and I could specify UDP here, for example. And in that case, I might specify a port number. I can change my source address to be a random address. So we're going to spoof our source address so it doesn't look like it's coming from me at all, and say that we want some data to go along with it as well. So basically, using hping, you can specify to a very minute level of detail exactly how you want your packet to look, and then you can send it off repeatedly to the host. This works out really well as a great tool just to interface with systems at the port level with different protocols to see how they respond, and you get very detailed responses back from hping. As I said, it's really not necessarily a port scan tool, although you could sort of create scripts around hping to turn it into a port scanning tool, but it is if you've got targeted ports that you want to interface with and you want to get really detailed information back at the protocol level, you can use hping, and it's great for that.